NASA's Hubble Space Telescope was capable of precisely gauging the mass of the most seasoned known planet in our Milky Way galaxy. The old planet has had a surprising history since it is in an improbable, brutal neighborhood. What is that neighborhood, and how could scientists gauge such an ancient planet? You can find out here. If you enjoy our videos, please support us by subscribing to Spaceverse and anticipate more exciting content in the future. Let's begin our journey through the immensity of the universe. PSR B1620-26b is a pulsar planet orbiting the pulsar PSR B1620-26 in the globular cluster M4. It is situated around 12,400 light-years away in the constellation Scorpio. Furthermore, this exoplanet is the oldest known, as it is believed to be 12.7 billion years old, with an estimated age of 13 billion years. The planet is over twice as old as the Earth, which is 4.5 billion years old. Almost 1 billion years after the birth of our universe in the Big Bang, it emerged from a young sun-like star. What's fascinating about this planet is that it orbits an unusual pair of worn-out stars in the crowded core of a cluster with over 100,000 stars. But how do we know that this object is a planet? Before our Sun and Earth even existed, a planet the size of Jupiter formed around a star with similarities to our Sun. Today, 13 billion years later, NASA's Hubble Space Telescope has precisely measured the mass of this most distant and ancient known planet. Hubble's analysis shows that the object has 2.5 times the mass of Jupiter, confirming it is indeed a planet. Its existence provides undeniable evidence that the first planets formed quickly, within a billion years of the Big Bang, leading astronomers to speculate that there could be many planets in our universe. The old planet has had a noteworthy history because it landed in an improbable and unforgiving area. It orbits a peculiar pair of worn-out stars in the dense center of a globular cluster. So, what's the story behind its discovery? The discovery of this planet began in 1988 when the pulsar PSR B1620-26 was found in M4 by astronomers led by Donald Backer. This pulsar is a neutron star that spins around 100 times per second, emitting regular radio pulses like a lighthouse beam. The white dwarf was quickly discovered due to its effect on the pulsar. As the two stars orbit each other twice a year, astronomers later noticed further abnormalities in the pulsar, indicating that a third object was also orbiting the pair. This third object was believed to be a planet, though astronomers also speculated it could be a brown dwarf or a small star. The debate about its true nature continued into the 1990s. The discussion was resolved when astronomers finally measured the planet's true mass. Through clever stellar detective work, they used Hubble data from the mid-1990s to study white dwarfs in M4. When they analyzed these observations, they were able to identify the white dwarf orbiting the pulsar and measure its color and temperature. Using evolutionary models calculated by Brad Hansen at the University of California, Los Angeles, astronomers estimated the mass of the white dwarf and subsequently the planet. As the planet passed through a double star system with an ancient neutron star and a white dwarf, the gravitational forces of the two systems contracted into a complex set of orbits. Soon after, the white dwarf was ejected from its original position and shot into space by the more massive planet. Meanwhile, the planet was tossed into a circumbinary orbit, a large orbit around both its original star and the neutron star. The new arrangement of the planet, its sun, and the neutron star has since experienced a so-called gravitational recoil, ejecting the white dwarf. This gravitational recoil pushed the new double star system out of the crowded core of the globular cluster into a less dense region, reducing the chance of further stellar interactions of this magnitude. The planet, in its new location within the globular cluster, slowly pulled into a long orbit around the neutron star and its progenitor star, at a distance of about 2 billion miles, similar to the orbit of Uranus around our Sun. From this vantage point, the planet witnessed the death of its progenitor star. Over the next billion years, the Sun-like star grew into a red giant, shedding matter onto the neutron star. The mass accretion onto the neutron star caused it to spin faster and faster, transforming it into a pulsar. Today, the neutron star completes almost 100 rotations per second, which is about 10 times faster than a hummingbird can beat its wings. Once the excess gas left the star, it transformed into a small, bright white dwarf with a helium core. Throughout all this, the planet remained in its expanded orbit, and this is the state the system was in when astronomers discovered the planet less than 30 years ago. But how did scientists confirm this planet's existence? Using Hubble data, scientists used the color and temperature of the white dwarf to determine its age and mass, which they compared with the wobbling of the neutron star. Additionally, radio studies of the pulsar showed anomalies in its signal that couldn't be caused by its companion star alone. Using this data, scientists calculated the inclination of the white dwarf's orbit, allowing astronomers to determine the mass of the third object, which was too small to be a brown dwarf or another star. The planet's orbit and its place in the globular cluster provide clues about its past. PSR B1620-26b, also known as Methuselah, is often referred to by its biblical name in recognition of its ancient status, similar to the oldest figure in Christian tradition. Methuselah is the only known planet to bear a biblical name, a testament to its immense age and the powerful mysteries of our universe.